Oops, wrong one. Okay, can somebody confirm you can hear me?
Yes.
Thank you. Before we begin, are there any questions?
Are we only having, or actually, never mind. I remembered you answered the quiz question on the last class.
Okay,
I do have a random question. I was going through the study guide throughout the lecture, and back on the lipid portion, the study guide said understand oil versus lard. Um, do you happen to know that or where it would be in the book?
I do not know where it is in the book, but oil is simply a liquid, lipid, and lard would be a solid uh, liquid. It is true that lard is a triglyceride and oil is not, but beyond that, I don't think there's a whole lot of difference.
Thank you. That's really
Okay,
helpful. Yeah, thank you.
all right, let's go to well, I gotta share my screen first. Here we go. The syllabus. So today is October 8th, and we are going to be doing Lab 3, Microscope Basics. Hopefully you've read the section of Chapter 3 discussing the compound light microscope. If you have not, you should do that before you begin Lab 3, and you should read it also before Lab 4. Any questions about any of that? If not, let's go to the lesson. Lab 3, Microscope Basics. Microscopes are expensive and easily damaged. As such, there is a certain protocol for handling them. Please follow these instructions carefully. There is some reading to do in the pre-lab. Please read the textbook chapter 3 through the end of the section on the compound light microscopy. There is some video clips for today's lab. I don't think there's an online exercise, but let me check on that. Oh yeah, there is an online exercise. Sorry, I forgot about that one. Um, so we'll go through that a little bit. Where am I? So the learning objectives for today is one, be able to locate and name the parts of the compound light microscope along with describing their functions. Two, calculate the total magnification for each objective lens used. Three, know the guidelines for focusing specimens with the different objectives. There are four different objectives on most compound light microscopes: the scanning objective, the low power or 10x lens, the high power or the 40x lens, and the oil immersion lens, also called the 100x lens. And then, what is that? One, two, three, four, estimate the size of a specimen when seen at different magnification powers. Five, understand the rules for proper microscope care. And then six, be able to define the terms associated with the microscope, including those discussed in this lab module and in the textbook. Any questions about these learning objectives? Put a space in there. All right. So when we're talking about the compound microscope, it's important for you to memorize the names and the functions of these parts of the microscope. One, the eyepiece or the ocular lens. Two, the objective lens. And there are four of them. You can only see three there. One, two, three. And actually, there's only two you can see here because there's one right behind the other. I don't know where the fourth one is. Must be behind one of these. But there's four objective lenses. And then three, the stage. For the stage clip, it holds the slide on the stage and then allows you to move the slide so you can view specimens in different locations or move the slide to look at a specimen. And how that's done was with five, the stage control knobs. Six is the iris diaphragm. And seven is the condenser lens. And on some microscopes, you'll note that the iris diaphragm is below the condenser. So they're always together, but this one has it above the condenser. It may be below the condenser. And then eight, the coarse focusing knob. Nine, the fine focusing knob. It's always the smaller one, the fine focusing. 10, the light switch for turning on the power of the microscope, the light. 11, I call it the rheostat. Apparently, they don't have that name in Australia or they don't use it. Uh, so the person who named it in the lab module calls it the light intensity dial, and either name is fine. 12 is the lamp or the light. And so know all of these parts of the microscope as well as the function of the parts. Any question about any of that?
Sorry, could you repeat what 9 was again? Or it says below.
It says below. 9 is the
Okay.
fine focusing knob.
Okay, thank you.
Yeah, they're all numbered down here. All right, so you need to know this table, and that is when we're using the different objective lenses and their power, the total magnification, the depth of field, the field of view, and then some comments. There are four objective lenses, and that's the scanning lens. I tend to call it the 4X lens. This is power. There's a low power lens, and this is an objective lens, and it's 10X power. There's the high power lens, and it's called the 40X lens, 40X power. And then there's the oil immersion lens, also called the 100X power. Please realize that if you're using the name, the low power lens is not the lowest. The scanning lens is the lowest power, and the high power lens is not the highest. The oil immersion lens is the highest. That's one reason why I do not like giving them their long English name. I prefer giving them the name with their power. Any question about any of that? In our compound microscopes that we have in the labs in Clark College, and I believe this is all of the labs, not just the microbiology lab, but certainly the microbiology lab, the ocular lens magnifies the object 10 times. And so the total magnification is the objective lens times the ocular lens. And because our ocular lenses are always 10 times, it'll be 10 times the power of the objective lens is the total magnification. You can have some microscopes with a different ocular lens. Like I've seen a child's microscope, but instead of being 10x, it actually was only 4x. And I've seen the best microscopes made, the most expensive, they'll have a 20x ocular lens. but for all of our microscopes, we have a 10x ocular lens. And so the total magnification is just 10 times the power of the scanning, the objective lens. Any question about any of that? So the total magnification is the power of the objective lens times the power of the ocular lens. The depth of field, let me get something to show you. Hopefully you can see this. The depth of field is how much of an object you can see in under the lens. The scanning lens has the deepest depth of field, where you can actually see both the top of the object and maybe the bottom of the object. The low power lens has a less depth of field, and it would be, instead of the entire object you can see, maybe you can see about half of the object. The 40x lens has even smaller depth of field. So instead of seeing half the object, you can see, I don't know, maybe less than a quarter of the object, but you can see more than just a single plane. With the oil immersion lens, the 100x lens, you're looking at essentially just one plane through the specimen. So you're not seeing the top of the specimen, not seeing the bottom of the specimen, you're only seeing one plane through the specimen. And then to look at the top, you have to focus in the top. And then to look at the bottom, you'd have to focus in on the bottom. And obviously to look in the middle, you have to focus in the middle. So that's the depth of field for the different lenses. The field of view is how much of the slide you can see under the microscope. So with the scanning lens, you have a very large field of view, the 4x lens. And then with the 10x lens, you have a smaller field of view. With the high power lens, you have an even smaller field of view. And then with the oil immersion lens, you're seeing really just a pinprick or a very narrow size. Any question about any of that? So the comments, the scanning lens is the easiest lens to use because you can see the object wherever it's focused, and then you're seeing the most slide under the microscope, so that wherever the specimen is, you're more likely to see it with the scanning lens, the 4x lens, than you would with a higher power lens like the 100x lens. And then the hardest to use lens, hardest to use objective lens, is the 100x lens because it is the smallest field of view. You're able to see the least amount of the slide under the objective lens, and then it has the very narrowest depth of field. Any question about any of that? All right, it's also noteworthy that when you're viewing an image under the microscope, not only is it magnified, but it is also inverted and reversed. For the letter E, shown here, if you were to look at it under the microscope, it would look like this: magnified, inverted, and reversed. The iris diaphragm has a diameter which can be opened or closed, much like the shutter on a camera. If you're familiar with shutters on a camera, especially the old cameras where you actually had a shutter. I don't know what the digital ones have, but and so you can open up and allow more light to come in, or you can close it down to allow less light to come in. More importantly, though, the iris diaphragm affects the contrast between the specimen and the background of the slide. And so you usually want the contrast to be greatest, and that we call color illumination. And how you get color illumination is you open the iris diaphragm up to about the size of the field of view of the objective lens that you're using. This means that when you're starting to use the microscope, which you should be starting to use the microscope using the 4X lens, the iris diaphragm should be open fairly wide, open almost all the way, because the 4X lens has the largest field of view. And then as you go up in power, you should be shutting down the field of view until you get the 100X lens, which has the smallest field of view. And then you should shut down the iris diaphragm so that you're only getting essentially a pinprick of light coming through the iris diaphragm. And if you do that, you'll get the best contrast and the best observation you can make under the microscope. And they call that color illumination. The module also says the iris diaphragm is the most important tool for adjusting the light. If you need more light, you can open the iris diaphragm. If you need less light, you can shut the iris diaphragm. I will admit that if you state the rheostat is the most important tool for adjusting the light, I'm going to allow it because both the rheostat and the iris diaphragm can adjust the light. So obviously there's a question about that in the lab, and I will accept either answer. When you first use the microscope, you should be using the 4X lens. This is because with the 4X lens, you're most likely to see the specimen under the slide because you're seeing the most slide, and then you're going to be able to focus in the easiest with the 4X lens because it has the greatest depth of field. You should then adjust the light to the power you want. And then focus in on the specimen using the coarse focus adjustment knob to slowly raise the stage to bring the object into coarse focus. Then you use the fine focus knob to bring the object into fine focus. Any question about any of that? Excuse me here. Once you have the object in fine focus, you should never use the coarse focusing knob again. The reason for this is that the objective lenses are in parafocal vision, meaning whatever objective lens you're using, if you switch to another objective lens, the object should be in at least coarse focus where you can actually see the object, and you should only be able to use fine focus to get the object into fine focus. Any question about that? So you only use the coarse focusing knob when you're using the 4X lens. And then once you're done using the coarse focus and you start using the fine focus, you should only use the fine focus from now on. If ever you make a mistake and switch to the coarse focusing, you actually remove the perifocal vision. And so what you should do is just start all over, go back to the 4X lens, use the coarse focus to coarse focus, then use the fine focus to bring the object into fine focus. And now only use fine focus even when you switch the objective lenses. Any question about any of that? All right, before you switch lenses, once you have the specimen under fine focus with the 4X lens, you should move the specimen to the center of your field of view. And then you switch to the next higher objective lens, which in this case would be the 10X objective lens. And you need to do that, move the object to the center of your field of view, because if under the 4X lens, if your specimen were over here, and then you move up to the 10X lens, you no longer have the field of view this large. It's going to be something like this. And then your object will be over here outside of your field of view. So you need to move the object into the center of your field of view before you adjust to the next higher power objective lens. And if you need to, they should be in parafocal vision, but if you need to, only use the fine focus knob to bring it into fine focus. And then repeat steps 9 when you once again switch from one objective to the next higher lens, meaning when you're going from the 10X lens to the 40X objective lens, you should once again move the specimen to the center of your field of view before you move up to the next higher lens. And then if you need to, only use the fine focusing knob to focus in on the specimen. Any question about any of that? All right. Using the oil immersion lens requires the use of oil. If you don't use oil, the oil immersion lens will not give any better resolution than the 40X lens. And since the 40X lens is easier to use, you should only use the 40X lens if you're not using oil. If you want to use the oil immersion lens, you should put a drop of oil on, and that requires additional use, but the oil gives you additional resolution because oil has the same refractive index as glass, and this allows more light to go through the glass, go through the oil, and then go into the glass of the objective lens. And if you don't have that oil in there, the light will go through the glass and refract at the glass air interface, meaning bend, and then it'll also bend at the air glass interface of the objective lens. And you'll lose light each time the light refracts. So we use oil so that light won't be lost and you'll get better resolution. Any questions about any of that? I'll talk more about refraction when I talk in the lecture. But for now, that will do. How you do the oil is you take the 4X lens and move it halfway out and move the 100X lens halfway to where it's supposed to be. So neither lens is going to be right over the slide, right over the specimen. And that will allow you to come in with a drop of oil and put a drop of oil on the slide. And then you move the 100X lens over the drop of oil and the 100x lens is close enough to the slide so that, let's make this the drop of oil, so that when you move the 100x lens over the slide, the 100x lens will actually go through the oil, which is hard to show here. Maybe I can go below, behind it and show it. There you go. Kind of move it to my face, and maybe you can see. There you go. You can't see, but the objective lens is actually in the drop of oil. If ever you use oil, you need to clean oil off of the objective lens. And you need to clean it with lens paper and only lens paper. Any question about any of that? All right, let me state a little bit about lens paper. Lens paper is paper that has the wood fibers removed from the paper. Wood has fibers in it, and when you make paper out of it, the fiber is still there. Wood fibers can actually scratch glass, and that will scratch the lenses. And the lenses are the most important part of the microscope, the most expensive part. And if you get it scratched, you'll just impair your ability to view the specimen. So we don't ever use paper or chem wipes, which is paper, or paper towels, which are paper, whenever we're cleaning the lens. We only use lens paper. And it is true you could use Q-tips and cleaning fluid. However, in the past, it's only the instructor, meaning I, who have ever used the cleaning fluid and the Q-tips to clean the lenses. So the students only use lens paper. Any question about any of that? All right, so activities. In activity one, you're going to be getting the size of the field of view. Note for each of the objective lenses. Note online students are not going to perform this activity because it'd just be too difficult. You don't have access to a microscope. And therefore the table has already been filled in for you. However, you will be expected to know the information contained in the table and how to use the formula in point 5 below, which tells you the size of the field of view under the objective lens. So with the 4x objective lens, the diameter of field of view, how much of the slide you can see, is 4.5 millimeters. And for the 10x lens, the diameter of the field of view of the slide you can see under the objective lens is 1.8 millimeters. For the 40x lens, it is 0.45 millimeters. For the 100x lens, it is 0.18 millimeters. And you can know this either in millimeters or in micrometers. It's important to know the size of your field of view under each objective lens, because if I were to state something like the objective lens we're using is the 10x lens, and the size of the diameter the field of view is 1.8 millimeters, and you have a specimen that's taking up 50% of the field of view, what would then be the size of that specimen? All right, you guys got to contribute because I'm not going to give you the answer here. Just unmute your microscope and not microscope, unmute your microphone and provide an answer.
Would you just do the 1.8 and then divide that by 2 to get what the specimen size would be?
Yes.
So
And
it'd be zero point 0.9.
yes, you need to, yes, thank you very much. You need to be able to do this to get an estimate of the size of your specimen. Okay? And so that's why you need to know the size of the field of view that you can see with each of the objective lens so that you can get an estimate of the size of the specimen you're viewing. And normally we have students actually measure this out if you were to come into the lab. And what we do is we give you a ruler that has a metric on it, and the smallest marks on the ruler would be 1 millimeter. And you can imagine how difficult it is to obtain the measurement of the oil immersion lens if the smallest measurement on your ruler is 1 millimeter. But we're filling this in for you because you're doing it online and we know you can't measure it. All right, so it's stated, where's 5 below here? Oh, here it is here. For getting the diameter of the field of view, you can go through this formula to getting the diameter of your field of view. However, it's much easier, at least in my opinion, simply to use this table here for the size of the field of view. Okay? Any questions about any of that? You do need to either know this formula or know the sizes of the field of view for the different scanning, the different objective lenses. All right. Activity 2, online students are not going to perform this activity, but you will be doing a virtual exercise of this activity by completing the laboratory exercise at the end of this document. We expect that you'll know and understand the material and that exercise. So you can read through activity 2 because you need to know how to do this, how to use a microscope. And you will do it under the virtual microscope. Activity 3, online students are not going to perform this activity because you don't have a microscope to do it. But if you haven't made a wet mount and you don't know what a wet mount is, you should read activity 3. You're not going to be tested on this procedure, but you should know how to make a wet mount if you're taking microbiology. A wet mount is something very important. In fact, we when we are doing the unknown project, you might do a wet mount to determine if your bacteria, your unknown bacteria, has a what is that called? Just a minute, I'm drawing a blank here. A capsule. So you might make a wet mount to determine whether your unknown has a capsule. Um, a wet mount is something hopefully you did in Biology 160, and if you have not, you should read how to make a wet mount. Activity 4, you're not going to be handling a real microscope, but these steps must be performed prior to storing your microscope away. You must know this. You'll be quizzed on this material. You must lower the stage all the way. You must remove the slide. If you use oil, you have to wipe oil off the 100x objective lens because there will be oil on the 100x lens if you use oil. Another thing is that if you move the 40x lens around, meaning you're switching objective lenses, once you've added oil to the slide, if you move the 40x lens over the drop of oil, the 40x lens is low enough that it will get in that drop of oil. So you should check the 40x lens to see if it has oil on it. So check both the 100x lens and the 40x lens and remove the oil from both if oil is on both. You should also put the 4x lens in place before you put the microscope away. you should lower the intensity of the light and then switch the light switch to off, unplug the microscope, and wrap the cord around the microscope neatly. We don't do number 7, so you can skip that one. And then always use both hands when you're carrying the microscope. One hand on the arm of the microscope, one hand underneath the microscope to support the microscope in case, I don't know, you drop it with one. Place the microscope back in the same cupboard you got it from in the same way you put it in. So here you can see this cup maybe, kind of, and that is the microscope will go in with the objective lenses in the front and then the ocular lenses, I'm trying to show you, in the back. So put the microscope away the same way it was when you pulled it out, meaning always put the microscope away the same way, in the same position. They actually have numbers, so that you would put it in whatever number cupboard, whichever microscope number you have. Misuse and mistreatments of the microscope would result in a penalty. Obviously, we're an online class, so this one isn't correct, but you will be graded on your treatment of the microscope. Quiz, meaning. All right, know the terms of the microscope? And let's go down here. Come on. So laboratory exercises. There are some video clips to watch on general microscope focusing technique, and then putting oil on the microscope for using the oil immersion lens. So there's 2 videos to watch. And then 2, practice your microscope skills by using the virtual microscope. And there will be a question in the worksheet for from the virtual microscope. Let me open that. Once this opens, if you don't have a fast internet connection, this may take a little while to download. As you can see, I have a pretty fast internet, and it's taking a little while to download. And then this page will come up, and there's a guide you can read about the learn, the explore, the test, and some options for using the microscope. Let's go into the explore. The question mark is the thing to select, and so click there. And let me see if I can remember which slide to use. I think it's the last question. Onion root tip cells. I actually changed that, but we'll leave it there now. So we want to take a look at the onion root cells. Oops, wrong one. There we go. So plant slides, onion root. And there we're looking at the specimen. As you can see, it's not well focused. So what you want to do is first adjust the light. And then maybe we'll wait until we get it in better focus. Use the coarse focus, get it in approximate focus, and then use the fine focus. Move the specimen you want to observe into the center of the field of view. And right now I can't see any, but and then go and use the 10x lens. Let's adjust the light a little bit. Still not seeing what I want to see. That might be it there, but let's use the fine focus now. Get it in fine focus. Go up I'm still not seeing what I want to see, so it's hard to move it in the center of the field of view. Yeah, there's some chromosomes. That's not a good one, though. It's not showing you. Oh, there's some. They're split, though. Um, let's go back. See if I can move it around. Moving the slide around. There's the one. There's a picture with showing you the chromosomes, and fine focus on it, and then go up to 100x power. For 100x power, you got to add oil. And there's the oil there, so click on the oil. Puts a drop of oil in, and you'll notice it's not going to be in fine focus now, so we need to fine focus. And let me see if I can find the slide I was looking at. That's not it. It looks like it's moved because I'm not seeing the one again. Let's go back to the 40x lens and see if it's still there. I have oil on the lens paper, and so on the objective lens, so it wants to remove the oil. So there's the lens paper there. Click there. There we're cleaning oil off the 100x lens. I'm not sure why that isn't focusing. That should be the one we're looking in. And when I go up to the 40x lens, 100x lens, it's not there anymore. Oh, there it is, right there. I'm not seeing all of it, but there's part of it. Anyways, that's how you use the virtual microscope. And I'm going to end it now, and so it wants to clean it again. And then that puts the slide over here. And it's too bad you don't have for putting the microscope away, but remember to lower the stage, adjust the rheostat to low, remove the slide, which you did, and then turn the light switch off. You don't have a cord here on this one, but you'd wrap it around the microscope and then put it away. All right, let's go to the questions. Don't use the questions in the lab module because they've been changed. Use only the questions in the worksheet. Which this might be the worksheet. Yep, it is. And only turn in the worksheet. If everybody turns in the lab module, my web page would soon become full, and then you guys would not be able to turn in any future assignments. So only turn in the worksheet because they are smaller. Uh, so do number one, do number two, which we've already discussed. Practice naming the microscope parts. You can come to this page and open it. And then you get a quiz. Press play to begin. There's the play. And it's saying, where's the light source? Light source is right here. If you get the correct answer, the dot will turn green. It's blue at the start. And now it's saying the diaphragm. Let me show you what happens when you get it wrong. Let's go here. You get a funny sound. And then let's go to the diaphragm. It's yellow because you didn't get it correct on the first time. Now let's go 3 wrong. Body tube, let's go here. Here. Oops, I meant to do that 3 times. Sorry, let's go again. Stage clips. So that's there. Let's not do there. Let's go there, there, there. And then it gives you the answer if you get 3 missing and it's purple. And red means you got more than 2 wrong. Any question about how to use this? Anyways, this will help you learn the different parts of the microscope. In the Canvas web page, see if I can find that. There's also quizzes on the microscope. I think it's with, no, I'm wrong. It's the quiz is only on this lab. The quiz I'm thinking of is the metric quiz, and we haven't talked about that yet. Sorry. So we'll talk about that when we're talking about metrics. So this is the only quiz I have on the microscope. And then answer the questions for number 4, fill in the blanks with the correct answer. When focusing a specimen, you should always start with which objective lens. B, when using low power, high power, and oil objective, only use which focus adjustment knob, the coarse focus or the fine focus. And then for C, the type of microscope used in the lab is what? And it's a 2-word answer. And don't tell me the type of microscope, like the Nikon microscope, because that is wrong. Not all the microscopes are Nikon. I'll give you a hint. It's not a simple microscope. And then 4D, you should carry the microscope by holding on to what part of the microscope with one hand and supporting the other part of the microscope with one hand. 4E, the objectives are attached to this part of the microscope, which can be rotated to click different objective lenses into place. So name that part. If a microscope had an ocular lens of 10x and a high power objective of 40x, what would be the total magnification? So give me the total magnification there. When the stage is moved left, the image through the ocular moves in which direction? When the stage is moved forward, the image viewed through the ocular moves in which direction? Give the answer there. Which objective lens provides the largest field of view? So name the objective lens. Which objective lens has the smallest field of view? Name it there. Of the methods for light adjustment, what is the most important on the microscope? So name it there. And then 4K, how large is the field of view when using the high power objective lens? Answer in millimeters or micrometers. Do not say simply small, because that will be a wrong answer. And then how many chromosomes are in the onion root tip cells? Answer that there. And then 2, suppose a typical bacterial cell is 2 micrometers in diameter. In the circle below, which represents the field of view, when viewed with the oil immersion objective lens, state how many cells can fit across the circle under the oil immersion lens. Show your calculations for full credit. If you only give the answer and it's correct, you only get partial credit. So you need to show how you got your answer for full credit. And I want to see the mathematics, because if you're getting it wrong, I'll try and help you with the math. All right, that's it. Any questions on this lab? If not, go ahead and get started. I'll be here until 8 o'clock to help you answer questions on the lab, or until the last student logs out. Once the last student logs out, I'll stop I'll log out as well.
I um I looked and I saw that the worksheet that's not attached with the module is missing the last question, part L of like the onion root tips.
Thank you. Let me upload that. Obviously, I need to do that. I didn't realize that was the case. Um,
I just added the question on the bottom of my worksheet. Is that fine? And just kind of like do that.
I'm sorry.
Oh, I added the question for L just onto my worksheet. Is that fine? I don't have to like re-download the
Yeah, if
PDF.
you're already finished, I'm going to upload it right now, but
Oh, cool.
I'm trying to do that right now. I probably have a different question, but that different question will be fine. Okay, I just uploaded the worksheet. Let me upload the lab module as well. I don't have the lab module here. Well, we'll go the teacher's version. Now let me check. Come on. Ooh. Let's remove that one. So I didn't put that one up there. I was not using that anymore. See. All right, I have the new worksheet up. And let me check to make sure it's good. Oh, that's to lab 2. We're not on lab 2, we're on lab 3. Sorry, let me check. There it is.
I had a question on it was the number 4 question 2
Uh-huh.
about the bacterial cell. Um, so if I'm using the table correctly, hopefully I am, wouldn't you put, since it's 2 micrometers um, in diameter, wouldn't you do, since it's the oil immersion, it would be in diameter 0.18 divided by 2 to give you the 0.09?
Um, I'm sorry, I'm doing something else, so let me hold off a second and I'll get to you.
Okay.
So, oil immersion. Come on. That's right. Okay, can you give me that again?
Yeah. So would it be 0.18, which is the diameter of the oil immersion over divided by 2, because that's the micrometers, which would give you the 0.09 for the answer?
Um, Something's wrong with your units, but other than that, you have the right concept. How many cells? It's not going to be 0.09 cells.
Oh, I don't know. I guess I'm
One
just really
thing,
confused at this
one
one.
thing, let me explain. I know what your problem is. And
Mhm.
you're taking uh, the diameter in millimeters divided by 2, which is in micrometers. Does that make sense? And that's why you're getting 0.09.
Oh, okay.
So you need to either switch one of the units to micrometers or switch the other one to millimeters
Okay. So
or
let
multiply
me
one of them.
see. Let me see. So then it would be, oh, okay. So I got it. So it should be 180 divided by 2,
Correct.
which would give you 90. Oh, okay. I'm so sorry. I read the table wrong. That
Fine.
makes a lot more sense.
To piggyback off of that, do you want us to draw the 90 bacterial cells in the
No,
circle?
you don't.
Oh, okay, great.
So you just want us to leave the circle that indicates the field of view blank.
Correct. You can write your answer in there, but essentially you don't need to draw it. Is that what the question says? That's the way it used to say it, but I thought I changed that wording.
It just
You,
says represent like the
Yeah,
field of
yeah,
view by how
it
many.
doesn't say to draw it in, so you're fine. It used to,
Okay,
I decided to try and draw that many would just be too difficult.
gotcha.
All right, just show your calculations for full credit.
Okay, perfect.
Mine won't let me write the answer inside the circle. Can I just leave it to the
Yeah,
side?
to the side or below is fine.
Okay, thank you.
okay, my last weird question about 4L is for the chromosomes in the onion root tip. Do you want us, is it like similar to when we were talking about the bacteria colonies and you guess your best answer? Or is there like one correct number that we should be seeing?
You should be giving your best answer.
Perfect, can do.
Sorry, to follow up on that question about L for the chromosomes.
Mhm.
I got 16 chromosomes. I feel like that's a little too high of a number.
Just give your best estimate of your count.
Okay.
I also got 16, so Melissa, we're in the same boat. If
Okay,
that's what
perfect.
you
I was
got.
like, I was thinking that was a bit much, but maybe I'm okay then.
Yeah,
Thank
that's
you.
more than I actually see, but that's all right.
I know. Okay. But the chromosomes are linear. That's a cell that I'm seeing.
The chromosomes are eukaryotes, so yes, they are linear.
Linear. Okay, perfect.